Chapter 3 takes us into polynomials. So we're going to start today with a little bit of vocabulary because we've got to know what a polynomial is. And you've worked with polynomials lots, so you just probably don't use that vocabulary. So definition I have up here for a polynomial, it's the sum or difference of one or more terms that are called monomials. Okay, so polynomial, when we're factoring, those are polynomials we're factoring. When we take something like x squared minus 6x plus 24 and we factor that, that's a polynomial. Okay, when you're adding and subtracting those individual terms. Okay, a monomial, those are the individual pieces, the single pieces. It can be a real number, it can be a variable, or it can be a product of real numbers and variables with whole number exponents. So that could be something like x. It could be something like 3. It could be something like 3x squared. Okay, just single terms. We're going to talk about these next 3 things in some of our examples, and you're going to do several of these in homework. We're going to talk about standard form of a polynomial. When we talk about standard form, that is when your terms are arranged in, officially here it says descending numerical order, largest power to smallest power. So typically how we see, I'm going to keep going back to it, the ones we factor. When we go to factor something, it's usually x squared, then the x term, and then the number term. That's standard form when we go from highest power to lowest power. We're going to talk about the degree of a polynomial, which the degree is the greatest degree or the highest power. Okay, so the x squared plus 2x minus 3, that's degree 2 because that highest power is 2. And then we're going to talk about the leading coefficient. Leading coefficient refers to the non-zero factor that is multiplied by the greatest power of x. So your highest powered term, your leading coefficient is whatever number is out in front of it. Okay, so you've got the vocabulary there. You can go back and look at those definitions. Now, you have a chart here, and this chart is going to help us as we're classifying our polynomials. I mentioned when we talk about degrees, it's the highest power. Okay, so degree right there, it's the greatest degree or power. I don't remember which the homework does, if they name them by numbers or if they go by name. Okay, for instance, like the one I keep talking about, highest degree 2, by name, that is a quadratic. Okay, if the highest degree is 3, it's a cubic. 4 and 5 we don't see as much, but they have names. If the highest degree is 4, it's a quartic. If the highest degree is 5, it's a quintic. You would probably know linear. If we have our y equals mx plus b form, right? So y equals 6x minus 7, that's linear if the highest degree is 1. And then if the degree is 0, that's basically saying if there is no x, then that's just a constant, okay? Because there's no x, it's just a number. We're also going to name them based on the number of terms. So if you've got one term, nothing added or subtracted, just one single term, it's a monomial. Binomial is 2 things added together. Think bicycle, right? The bicycle is 2 terms added together, a binomial. Then a trinomial is 3 terms added together. And then past 3, we don't have specific names. So like 4 terms, polynomial with 4 terms. We don't have a specific name there. So we're going to use this chart. You're going to want to have it in front of you. You're going to want to have it available when you do homework. We're going to use it for a section like this. You're going to see several of these in homework. 3 questions. What is each polynomial written in standard form? What is the leading coefficient? And the degree. Okay, maybe 4 questions? Okay, I forgot one. Standard form, leading coefficient, degree, and number of terms. So, let's start with standard form. Thoughts on what standard form is going to be?
2x squared minus 4x plus 9.
You guys like it? She said 2x squared minus 4x plus 9. Highest power, yes. So our x squared term is first. Then our x is the first term. Then our term that has no x. That's your standard form. Notice signs go with the terms, of course, right? You've been there, done this. Old news. Okay. Let's talk about leading coefficient. What is that leading coefficient? It is part of 2x squared. The leading coefficient is just the 2. Now, probably better specify which 2. But which 2? There's a 2 and there's a 2. Okay, the big 2. Leading coefficient, remember coefficient is a number out in front of x. So that big 2 right there. There's your leading coefficient. What's my degree?
4. No.
Degree is 2. Now what 2 is that? Yeah, that's the power of 2, isn't it? Okay, so degree being your highest power. I have 2 written in my notes. If we gave a name, what would that be as a name? If you go back up to that chart, when the highest power is 2, we call that quadratic. And what else am I forgetting? Number of terms. How many terms are there?
3.
3. There's 3 terms added or subtracted together, yes? What is that in words? If you go to that chart above, when there's 3 terms, it is a trinomial. Okay. In my notes, I just have degree 2 and number of terms 3. So it's very possible that you might not have to worry about the words in homework. I don't really remember. I set up Sophos before fall break, so I don't remember off the top of my head. Okay. So, okay, B. 2x minus 3x to the 5th plus 6 minus 5x cubed. Let's start with standard form. What do you got, Paul?
Negative 3x5 minus 5x3 plus 2x plus 6.
Okay. Negative 3x to the 5th minus 5x to the 3rd plus 2x plus 6. Bless you. You kept all the appropriate signs in front of the appropriate terms. Standard form. Highest power, right? Power 5, power 3, power invisible 1, power invisible 0. Okay? Leading coefficient. Actually, I'm going to abbreviate. What was it?
-3.
Okay. Leading coefficient is negative 3. It's that number out in front of your first term.
Could it be -5? Like, oh, never mind. Just have different powers.
Right. Okay. Degree.
5.
Degree 5 because the highest power is 5, yes. In terms of words, that is called quintic. And number of terms. We have 4 pieces added or subtracted together, right? So there are 4 terms. And if you look at the chart, that doesn't have a name. It's just polynomial with 4 terms. So kind of generic there. Okay, C. Okay, standard form.
4x cubed.
4x cubed plus 2x cubed minus 3x squared plus x squared.
Can you average together?
Oh,
So it's, you do like 6x cubed.
It's like the same thing.
Yeah.
Okay.
6x.
So it's not a question of, out of our cubes, does 2x cubed or 4x cubed go first? That's not the question. It's, if there's two, if you're asking yourself which goes first because they have the same power, that means we need to add them together, right? So the fact that 2x cubed and 4x cubed are like terms, 2x plus 4x, or 2x cubed plus 4x cubed is going to be 6x cubed. And then x squared minus 3x squared. So that's going to be 1 minus 3 is going to be minus 2x squared. So standard form, you don't have repeat powers. Combine like terms, right? Okay. Leading coefficient. Okay. Use that standard form, right? Use what you've put together. Leading coefficient is 6. Degree. Highest power is 3. And so that is a cubic. And number of terms. Yeah. Again, use that standard form, right? Don't go back to the original. Use that standard form. Once we combined it, got it all nice looking. There are only 2 terms, which is a binomial. Okay? That's review, isn't it? You've been there, done that in Algebra 1, maybe pre-algebra. That's not new news. So it's just a matter of reviewing it, getting it to come back to us. Okay. At the bottom of the front page is a chart, and this chart comes from our book, and it's what we call end behavior. So we're going to look a lot at end behavior here. And end behavior of a graph is what the graph does as the graph goes off to the left and as the graph goes off to the right. Is it going up? Is it going down? Is it just going off to the side? But what is that graph doing? So now, end behavior depends on the degree of the polynomial and the sign of its leading coefficient. So we just spent some time talking about degree and the leading coefficient, didn't we? And that's what determines the end behavior. So even if I don't have a picture of the graph to look at, if I can see that first term, and I know what degree it is, and I know what sign it is, whether it's positive or negative, I know what my graph is going to do. So for instance, if my degree is odd, so 1, 3, 5, 7, 9, so on and so forth, and if my leading coefficient is positive, I know my graph is going to look like this, okay? I had a book that called this down and up behavior because the graph goes down on the left and up on the right. This would be an example. Y equals x cubed does this. You guys know enough to picture the graph of y equals x cubed or not? No. Y equals x cubed does that right there. Okay, and that's a graph we'll look at some. But here's the deal. That is an odd power, right? That is an odd degree. And it's a positive leading coefficient, y equals x cubed. Now, do I dare jump for a moment? Let's jump to the third picture. Degree is odd again. So again, that's your 1, 3, 5, 7, right? Leading coefficient negative. So an example of this would be something like y equals negative x cubed. And if we talk y equals negative x cubed, think about that negative. We've talked about a negative out front of a function. It takes the graph and reflects it. And if that's going to reflect it upside down, that graph looks like that. And so when there's an odd degree and a negative coefficient, my graph is going to have up and down behavior. So it's going to be up on the left, and it's going to be down on the right. Okay? Now, that is when my degree is odd. I would like to think you know a little bit about something if your degree is even. You do. What graph have we talked about all year long?
Oh,
Um,
you.
what
A U, yes?
Oh,
Parabolas, yes? Okay, see, we remember a little bit. Y equals x squared. Think, y equals x squared, that is an even degree, right? Degrees of 2, 4, 6, 8, 10, whatever even number you want to throw out there. Okay, an even degree. If the leading coefficient is positive, my graph goes up on either end. You guys know this because you know a parabola. Now, does end behavior tell us anything about what the graph does in the middle? No. Your graph can go up and up on either end. It can go up and down a whole bunch in the middle. But this is just talking about end behavior. So I had a book, again, my book that used up and down, it called this up and up, if that helps you remember. Okay? What's different over here? Down and down in behavior, that's going to be an even degree, yes, but what's different? It's going to have a negative lead coefficient. So for example, what does y equals negative x squared look like? That's an upside down parabola, isn't it? Okay, and these are just examples. Are these the only options? No, this is just me throwing some examples out here to try and give you an idea. Okay, so odd degree, if it's positive, it starts down, it ends up. An even degree, if it's positive, it's going to start up and end up. An odd degree, if it's negative coefficient, this time it's going to start up and end down. Even degree, if it's negative, it's going to start down and end down. Okay? That chart is a chart that will be very helpful as you work to get this figured out. Okay? Now, when we talk about end behavior, okay, we're going to have to be flipping back and forth to that chart some, I guess. But when we talk about that chart, we kind of approach our first idea of talking about limits, and we talk about whether graphs approach positive or negative infinity. Okay, let's see, how do I want to do this? So, as this graph, if a graph is going down, here, let me get to our first example. I'll use the example to help explain it. So, we're going to see some of these in homework, where it asks us to use the leading coefficient and the degree, okay, the two pieces we know, to determine the end behavior. So first of all, as we look at A, we have a big, long f of x function there. What do you know about f of x there? I can read the whole thing, but I don't really need to. What do we know? Okay, it's like y. So this is y equals 2x to 6 minus 5x to 5th. We've got like, what, 7 terms there or something. What's the degree of this?
6.
The highest power, which is 6. What do you know about the number 6? Is the degree even or odd? And we all know that the degree is even. Okay? What do you know about the lead coefficient?
It's positive.
Okay, the lead coefficient is 2. Most importantly, this 2 is positive, yes? Okay, look back to that chart. What kind of end behavior are we looking at if you have an even degree and a positive coefficient?
Up and up.
It's up and up, yes? In other words, for your little visual here, it's up and up, because it's just like saying y equals x squared. Okay. Now, they're going to ask me 2 questions. As x, and this arrow means approaches, as x approaches negative infinity, what is the behavior of the graph? And as x approaches positive infinity, what is the behavior of the graph? So as x approaches negative infinity, this is saying as you go left. As you go left here, what is my graph doing on the left-hand side? It's going where? It's going up. Is up positive infinity or negative infinity? Positive infinity, yes. So as x approaches negative infinity, that's saying left or right. So as x goes negative, so as we go left, my graph is going to go up. What is it that's going up? Not the x values, but the y values. So we're going to say y approaches positive infinity. And that's fancy for saying my graph is going up. Okay? So as x approaches negative infinity, as your graph moves to the left, my graph is going up. So as x approaches positive infinity, what is this asking? As my graph goes where? As x approaches positive infinity is saying as your graph goes to the right, where's my graph going? Where's my graph going here according to this even positive degree? It's going up. How do I express up? Y is going to also approach positive infinity. Okay? So you'll see infinities, I think, in homework. I don't remember if you have to type them in sometimes. Sometimes they're multiple choice, I know. It's fancy speak for if they use x, left or right, if they use y, up or down. That's what it's fancy speak for. Okay, think you can try the next one?
Yeah.
Okay, let's look at B. What do we know about this g of x function?
It's the same as the one on top. Positive. Never mind. Line.
G of x is negative 5x cubed plus 8x plus 4. What's my degree?
7.
I went across the page to B.
Oh,
I think you're going down the
Yeah.
page to C.
you're right.
Okay. I'm like, you are throwing out numbers that do not match this problem. That's fine. You can do that one if you want. We'll catch up with you later. Okay, what do you guys know about G? Its degree is?
No, positive. Oh, I know.
The degree
It's positive.
is 3. And what do we know about 3? We don't care about positive or negative. We care the fact that it is odd. What do we know about the lead coefficient?
Negative.
It is a negative lead coefficient. What does my graph look like? So if it's odd, I know it's either up, down, or down, up. If it's negative, which way is it?
Up and down.
It starts up and ends down, yes? And I'm just getting this, I didn't flip my screen, but you realize I'm just getting this from this chart right here, yes? I'm not making magic happen. I'm going back to my chart. If anyone's confused about where I'm making this magic happen, okay? So, as x approaches negative infinity, that's saying what? As my graph moves to the left. Where's my graph going on the left side? It's going up. How do we say up? Y approaches positive infinity. Good. As x approaches positive infinity. So what's this question asking me? As your graph goes to the right, what is it doing? What is my graph doing on the right?
Y approaches.
It's going down, which is what?
Negative infinity.
Y approaches negative infinity. So that is the fancy way for answering down. Are we catching on?
Yeah.
I'm trying to make it easy to understand. Okay, let's go try example C here. H of x equals 2x squared plus x to the 7th minus 6 minus 5x. what do we know about h of x that is important for in behavior? The degree is what?
2,
Two.
which is even.
I disagree.
Seven.
Wait. Oh, wait. Okay. I was looking at the.
Why is the degree 7?
X.
It's the highest.
It's the highest power. Okay, it's the highest power. What's the trick here? It's not in standard form for us, is it?
Yeah.
Okay, can they do that trick to us? Will they do that trick to us? Yes. Make sure, you don't have to rewrite this in standard form, but check. Where is the highest power, right? So my highest power of 7, we know 7 is odd. What do we know about this x to the 7th term? It's a leading coefficient of +1, which is positive, right? So, an odd, okay, I know odd goes opposite directions, either up, down, or down, up. What if it's positive? It's going to start down and end up. Okay, so as x approaches negative infinity, what do you know? What does y approach?
Negative.
So as my graph goes left, it's going down. So y approaches negative infinity. And obviously, do you need to write all these left, rights, up, and downs in? Absolutely not. Are they helpful to you if you write them in? Maybe. You do you. Okay, what about as x approaches positive infinity? What's my graph doing? It's going up, and so y is approaching positive infinity. Because that was asking me about on the right. Okay, one more in this section. Jx is 5x minus 3x to the 4th. What's my degree?
Even.
It's even because it is the 4. Are they trying to trick you again?
No.
You didn't fall for it this time, right? It's an even degree. What kind of coefficient?
Negative.
Negative.
It is negative. Okay, do you even have to look at the chart? If it's even, that means it's like a parabola, right? So it's either up, up, or down, down. What's the negative make us do?
Down.
Makes it that parabola upside down, so down and down, yes? If you want to cheat, what are both answers here?
Negative.
What?
Y approaches negative infinity, yes? Both sides are going down. As you go left, y approaches negative infinity. And as we approach, or as we go to the right, y approaches negative infinity. Okay. That's leading us into limits. And I know that doesn't mean much to you guys right now, but that's a thing in pre-calc and really a big thing in calc. But that's leading us into limits, is as x approaches positive, negative infinities, those type of things. Okay. Use that chart on the previous page to help you. Okay. When you get into homework, use that chart to help you, but also work to figure out, without using the chart, how this works. We have one more topic to do here. Okay. And you guys know on Savvis, this is going to be multiple choice. They're not going to have you sketching a graph, okay? But we're going to practice here. Now, when it says sketch, is it going to be identical? Is it, it's not going to be identical. There's various answers. It could all be right. But it gives us some information, and it asks us to sketch this graph. Did they give me an equation that I could cheat and plug in on Desmos? No. Okay, they're giving me clues. And we have to sketch a graph based on these clues. So, they tell us where f of x is positive. They tell us where f of x is negative. They tell us where f of x is decreasing and where it is increasing. Okay, those are all the pieces of information they give me. Now, is this why we're all staring at the screen?
Yes.
There must be an announcement issue. Okay. Let's start with increasing and decreasing. If a graph is increasing or decreasing, what's that mean to you?
Going up or down.
It's going up or down, right? If a graph is decreasing on a certain intervals, it's going to be moving in a downward motion, yes? If a graph is increasing, what's it going to be doing? It's going to be moving in an upwards fashion. Okay? So right now, we know on what intervals it's going to be moving up or down. Now, we're talking about where it's positive. Where is a graph positive?
Above the x-axis.
Right. And we've talked about this somewhere along the line, right? I know we did. But when a graph is positive, we're looking for above the x-axis. Remember when we solved inequalities? Okay? When a graph was positive, greater than 0, it was above the x-axis. When the graph is negative, we're going to be looking where? Below the x-axis. Now, they give me intervals that these are happening. Folks, these are all x's. Okay? All of these values are x values that we're using. We don't know anything about y values. We don't know how high this graph goes. I don't know how low this graph goes. I just know based on x values. So based on x values, what? I need to label at least over to positive 4 and at least over to negative 4, right? Label some numbers, don't label some numbers. I label every other number, just give me a little bit. Okay. So it is positive on the interval from negative infinity to negative 4. Where is negative infinity to negative 4? That is over to the left, yes? So what do we know of over here? To the left of negative 4, my graph is above the x-axis, right? I'm going to draw more in. This is where if I'm doing this in pencil, I'm kind of just lightly sketching pieces as I figure it out. Where else do we know? From negative 1 to 4, my graph is positive. So what's that saying? At negative 1 to 4, somewhere in there, my graph is positive and above the x-axis, right? I'm not connecting that yet because I'm looking for more information. But this is just kind of my indicators to myself that, okay, in those sections, it's going to be positive. Now, this should complement the information. It's negative on the interval from negative 4 to negative 1. Does that go with what I've already noticed? From negative 4 to negative 1, my graph is negative. That makes sense, doesn't it? And it's negative from 4 to infinity. So to the right of 4. That makes sense as well, doesn't it? Now, you almost can graph the graph right here, except they give us a little other information that we have to put into play. It's decreasing from negative infinity to negative 2.67. So negative infinity is over here, yes? Does that make sense that we're decreasing? Yeah, we can make this graph bigger now. How far are we decreasing to where? Yeah, a little bit before negative 2.5, so maybe right there we're decreasing to negative 2.67, something like that. And then we're also decreasing from 2 to infinity. Well, where are we at with 2? At 2, I'm supposed to be up above, right? So what's that mean about 2? 2 is going to be, We're decreasing from 2 to infinity, aren't we? Now, does this make sense with our last clue? Increasing from negative 2.67 to 2. Well, at negative 2.67, didn't I just stop decreasing here? And we're supposed to be increasing all the way over to 2. Okay. Does your graph look identical to my graph?
Yes, pretty close.
Probably pretty close, but does it have to look identical?
No.
No, it just has to have really the same shape,
All about interpretation.
okay? Could your graph go lower here at this, I'm going to use the word minimum. Could your graph go lower here? Could your graph go higher here at this maximum? Yeah, but the minimum needs to be underneath negative 2.67. The maximum needs to be above 2. I almost question if my max is above 2, but you get the idea, right? Okay. That's putting all the clues together. I know it's easier when the teacher's leading you through it. But again, stop and read the clues. It's doable. We've got one more. Ready to try and conquer it in the next 4 minutes? Oof. Okay, let's move. Use the information provided to sketch the graph. Well, again, I'm going to put the clues in here.
Good morning, students. Something I wanted to go over with you. I forgot in the announcements this morning. If you've noticed in the restrooms, we have upgraded. The stalls now have new partitions. We also have new faucets, new soap dispensers, and new paper towel dispensers in all of the bathrooms. The school spent about $100,000 on that. What I wanted to remind students is, in the past, we've had some vandalism, people tearing off soap dispensers, messing with the sinks and the partitions. Just note that if something like that's happening, please tell somebody if you see somebody tearing up our restrooms. This is the first big renovation project we've had at the high school in several years. We would like to keep our facilities looking nice. So please be respectful and take care of what we've spent money on. I know a lot of people have been asking for new bathroom partitions, and we finally were able to make it happen. So enjoy the new restroom facilities that we've upgraded, and thank you for doing your part to keep Tri-Central a great place to be. Thank you.
Okay, guys, real quick. I went ahead and wrote in my above, below, up and down arrows. I wrote in my -2, -1, 0, 1, 2. Okay, it's positive from -2 to -1. So positive means it's going to be above the x-axis there. And it's above the x-axis from 1 to 2. Yes? Okay. It's negative on these other intervals. This should make sense. This should complement what I've already said here. Negative infinity to -2. So before I get to -2, it's negative. -1 to 1, it's negative. And 2 to infinity, it's negative. Yes, it's below the x-axis. Now, here's the key. Where are my mins and maxes, right? That's what my increasing, decreasing. We're increasing from negative infinity to negative 1.5. So that means right here in the middle, we're going to have a max, yes? Now, if you want to kind of go in order, I'm decreasing from negative 1.5 to 0. So to the y-axis. What am I doing from 0 to 1.5? Increasing. And from 1.5 to infinity, I am decreasing. Okay. That's the end of the notes. That's lesson 3.1. You have a homework in Savas that is listed, should be listed as due tomorrow. It should go pretty quick, pretty short. Make sure you get it done for tomorrow, please, okay? And check with me if you have test makeup. You have 2.7 in, chapter 2 review worksheet.